Hi guys, welcome back to my channel. If you are new here, I'm Rusiru, a software engineer. In this video, we'll learn about DNS or domain name system. Imagine if you had to remember the phone number of every person you want to call instead of just their name. That would make communication incredibly difficult, right? The same problem exists on the internet. Computers identify each other using numerical IP addresses like 142, 250, 191, 14. But humans are much better at remembering names like google.com. The domain name system, or DNS, solves this fundamental mismatch. DNS is often called the phone book of the internet, but it's actually much more sophisticated. It's a distributed hierarchical system that ensures no single point of failure while handling billions of name resolutions requests every day. Let's walk through the DNS hierarchy. At your local level, you have a recursive resolver. Think of this as your personal assistant who helps you find information. This is typically provided by your internet service provider or service like Google DNS or Cloudflare. The recursive resolver maintains a cache or recent lookups to speed up repeated requests. When the recursive resolver can't answer from its cache, it starts climbing the DNS hierarchy. At the top are the root name servers. There are only 13 of these logical servers worldwide. Though they are replicated across hundreds of physical servers, these root servers don't know the IP addresses of google.com, but they know which server handles the .com top-level domain. The TLD servers are responsible for specific top-level domains like .com, .org, .net, or country codes like .uk or .d. The .com TLD server doesn't know google.com's IP address either, but it knows which authoritative DNS server is responsible for google.com domain. Finally, the authoritative DNS server is the definitive source. It's like the official registry office that has the actual IP address for google.com. Here's how it all works together. You type example.com into your browser, which sends a request to the recursive resolver asking what's the IP address of example.com. The recursive resolver, like your internet assistant, first check its local cache to see if it already knows the answer. If it doesn't, the resolver queries root server asking, where can I find the server for the .com domain? The root server responds, I don't know the IP, but here's where the .com servers are. Next, the resolver contacts a .com TLD server and asks, where is example.com handle? The TLD server replies, talk to the authoritative server for example.com. The resolver then asks the authoritative server, what is the IP address for example.com? The server holds the actual DNS record and replies, the IP address is 192.162.1 and 100. The recursive resolver forwards this IP back to your browser and caches the result to speed up future lookups. And just like that, your browser knows where to go to load the website. DNS resolution complete. This entire process usually happens in milliseconds, which is what makes the web feel instant. The beauty of this system is its distributed nature. No single server knows everything, but the system as a whole can resolve any domain name. It's scalable, resilient, and fast because of aggressive caching at every level. Here's something fascinating. DNS resolution happens before every web request, but it's usually invisible to users. However, DNS performance directly affects perceived web performance. If DNS is slow, website feels slow, even if the actual web servers are fast. This is why major companies like Cloudflare and Google provide free, fast DNS services. DNS gets your request to the right servers, and HTTPS ensures secure communication. But there's still one more piece of the puzzle for optimal web performance. How do companies like Netflix stream to millions of users simultaneously without overwhelming their servers? The answer lies in content delivery networks. Let's talk about content delivery networks, or CDNs, in the next video. If you have any questions, please leave it in the comment section. Don't forget to like and subscribe as we are continuing this series and building a solid knowledge on system design. I will see you in the next video. Thank you for watching. Have a great week.